polynomials and how to graph these and factor them and solve these kinds of expressions. We are starting out with ones that we're most familiar with, which is the quadratic. We've already talked about the basic quadratic, graphing our x squared, doing our transformations with it. We are going to start here then, because starting next week, towards the end of next week, we will be extending some of these concepts to higher order polynomials. So we will be eventually looking at like x cubed next to the fourth, and how do we get accurate graphs for those kinds of things. First thing on your handout, I do want to put in the definition of a polynomial because this chapter is all about polynomials, not just quadratics. The quadratic is a special case where your highest power of x is 2. Make sure you're taking notes right now and following along with us. So here is your function. That's what you're filling in on your notes handout there. The a's just represent coefficients, so whatever number is in front. Then your exponent is your power on x. In a polynomial, those are all whole numbers, so 0, 1, 2, 3, no fractions or decimals. So, with our polynomials, some things that you might be asked are to find your degree, leading coefficient, and constant terms. So we need to know what those things represent. Your degree is just the highest power of x. So the biggest exponent we see is our degree. Coefficients are the numbers in front of our variable. The leading coefficient is the coefficient of the term with the highest exponent. A lot of times that's written first if it's written in standard form, high to low power, but it doesn't have to be. So you have to make sure you are looking at all of those. A constant term is a term without a variable. So just a number by itself. So if I look at these, I want to give the degree, leading coefficient, and constant for each. So the first one, what would our degree be? 1. Highest power of x is just 1. Leading coefficient. You find that term with the highest power of x, what's the coefficient of that term? What is our constant? -1, the number by itself. Second one, what's my degree? Leading coefficient. Looking at the x to the fourth, that was my highest power of x. What's the number in front of that term? 1. What's my constant? 0. There isn't a term without a variable. All right. Last one. What would be my degree here? 3. The highest exponent, it wasn't written first, that's okay. Highest exponent is 3. So what's our leading coefficient? It's not the one that's first, it's the one of the term with the highest power. So x cubed is my highest power. The coefficient of that term is negative 1/2. What is the constant term? 5. All right, do we understand the meaning of those things? Something to note, if you have f of x equals 0, that's called the zero polynomial, and the standard is to say that has no degree, because I can't specify. Isn't 0 the same thing as 0x, or 0x squared, or 0x to the third? So there isn't just a single x power that works there, so it has no degree. But if I say f of x is equal to 3, so it's just a constant, is 3 the same thing as 3x? No. What would the exponent have to be on that x to make them identical? 0, because anything to the 0 power becomes a 1. So if it's a constant other than 0, the degree is 0. Another way of thinking about it, degree is like how many variables. If I just say 5, how many variables are there? 0. There is no variable. Alright, so that's some of the general polynomial stuff. Today we want to specifically talk about a quadratic. What is a quadratic function? Has an x squared as our highest power. So it's anything of the form f of x equals ax squared plus bx plus c. What's the graph of a quadratic equation called? Parabola. And we've already seen that. That was one of our parent functions. All right, parabolas have two options. Either you have your normal upward facing parabola. Is it possible for it to be upside down? Yes. So parabolas will either open up or down. And that's what will decide if they have a maximum or a minimum point. If our parabola opens up, does it have a maximum or a minimum? Minimum. If it opens down, it has a maximum. What's the name of that max or min point? What's the word for that point? The highest or lowest point is called your vertex. Parabolas are symmetric, they're the same on both sides. Do you know the name of that magical line that would go down the middle? It acts kind of like one, but in this case it's just talking about a line of symmetry. It's the same on both sides. So the vertical line that would cut it in half is called an axis of symmetry. So a lot of times when you graph these, you would have to draw in your axis of symmetry, and then you knew your points were symmetric on both sides. Any questions there? So, for graphing these, our strategy kind of depends on what form it's written in. Standard form is that ax squared plus bx plus c. Vertex form is what we were seeing before on our last test when we could do transformations. All of our transformation rules stay the same. Nothing's changing there. let's start graphing these. And that's pretty much what we're going to do for the rest of the day here, talking about graphing these things. If I asked you to graph x squared plus 4x minus 4, is that written where I can use transformations to graph it? No. And so if I don't have a graphing calculator, I can't do transformations. We could always go back to our plotting points, right? So let's do that. So if I put in 0, what do we get out? If I put in 1, what do I get out? If I put in 2, what do we get out? 34 plus 8 minus 4. Okay? What's going to happen if I put in a 3? It's going to get bigger. So what kind of number should I put in? Okay, let's try a negative 1. So we get 1 minus 4 minus 4. So negative 7. Is that enough? No, we know it should be a parabola. I'm not seeing a parabola yet. Let's put in negative 2. So I would get 4 minus 8 minus 4. So negative. Still not really enough. So if I put in a negative 3, get 9 minus 12 minus 4, which is negative 7. Is that enough? Yeah. We're starting to see both sides. You could even draw in, we know that axis of symmetry, once you find the middle of your graph, it goes through the middle. So any points that you had, you could reflect across. For instance, this point is 4 away from my axis of symmetry, so you could go 4 the other direction. This one's 3 away, you could do 3 the other direction, or keep plugging points in to your T-chart. But I finally got a graph. Okay, this works. Is this a good option? What's the downside of trying to graph all these things by plotting points? It takes a long time. When were we done? Not until we found that vertex, right? What if my vertex had been at negative 3/4? Would we have found that very well? No. So this is time consuming, and if your vertex isn't nice, you're going to be plugging in a lot of points to try to get your graph. So it's really not the best way. Now, let's go ahead and practice domain and range of this one. What would my domain be? Domain is your possible x values going from left to right. Range is my y going from the bottom up. What is my lowest value? Negative 8. We hit it so it gets a bracket and goes up forever. So negative 8 to infinity. It's okay. It likes the lights right now. We'll leave eventually.
She don't like them.
That's okay too.
It's probably like the 8th wasp that has been in my room this year. I think there must be a wasp nest outside my room somewhere.
That's okay.
All right.
She's gonna be locked in on the wasp the rest of the class.
I mean, I have a fly swatter, but I don't think I can reach that, so. Time to shine. All right.
Did you hear her say that?
What?
I'm so confused. Did you hear her say that? Oh, okay. She said she did it. I looked at Chloe. Guys, I looked at Chloe. Okay, flip side.
So how would I graph it if I wanted to use transformations? It's like we were doing on our test. What would I have to do first? Yeah, we need our points for our parent function, don't we? So it's a parabola. 0 squared is 0. 1 squared is 1. 2 squared is 4. If you wanted, you could do 3, 9. -1, 1. -2, 2. -3, 9. Okay, what would my negative do? Reflect or flip over the x. What's the 2 do? Okay, so you can think about those transformations. The other way to think about it, outside is y, and it does what it says. So you're taking your y value times 2. Here's a y, or times -2. Here's a y value of 0. 0 times -2. Here's a y value of 1. 1 times -2. Here's a y value of 4. 4 times -2. Here's a y value of 1. 1 times -2. Here's 4. 4 times -2. So I flipped it upside down and I stretched, which made our graph get skinnier. Can you tell me domain and range? What's the domain? What would be the range? And the 0, would it have parenthesis or a bracket? I want you guys to do C. So draw your parent function, draw your transformation. What's the transformation this time? So I can take each point to the right 3 and down 1. Okay, did everybody get this? Make sure if you are doing transformations that you graph your parent function for me. What's the domain? And what's this range? Good. So the question is, how could I graph the functions that are written in standard form without plotting points? B and C were easy because they were written with vertex form, when I could find where my graph would end up. But if they're not written that way, how do we get there? And in Algebra 2, when you graph these, you guys had a formula you used for finding the vertex. It actually comes from completing the square. Now, if I wanted to write this one using transformations, we would kind of do that same thing we did with the circles. You know, you group your x's together. Divide by 2, square it. You guys remember doing that with our circles. So it comes from that. So you could complete the square every time. Or you can use the formula x equals the opposite of b over 2a. There is a second formula for the y, but I think that's silly to memorize that one. Then you just plug in x to get y. If you know what x is, there's no need in having a formula to calculate your y, you just plug it into your equation. So, if it's written in standard form, we can use the opposite of b over 2a. And remember, the vertex is an ordered pair, so xy is our answer. Use this one to get our x, plug that in to get y. Axis of symmetry is the vertical line that goes through the middle, so that is x equals, because it's a line, you have to have the equation, and it's just the x value of the vertex. So x equals the opposite of b over 2a. We can also use standard form to get the y-intercept. How do you find a y-intercept? Same thing we would do if we had a line. How do we find the intercepts of anything? We plug 0 in for x. If I want to know where you hit the y-axis, that means your x is 0. So, let's try that from a couple. This is written in standard form. If I want to get the vertex, we can use our formula to get our x. What's my b value? 2. So the opposite of b would be -2 over 2 times, what's our a? So we get -2 over 2, or -1. Then you need an ordered pair, so we need x and y. So if I plug -1 into my equation, you get -6. So my vertex is the ordered pair, -1, -6. That's just a point on your graph. Axis of symmetry. That's just x equals the x value of our vertex, which is -1. X equals -1. We just draw the axis of symmetry as a dashed line. It's not really an asymptote, we're just showing it's the middle of my graph here. Okay. If I wanted the y-intercept, how do I get that? Put 0 in for x. So I get -5. So I hit my y-axis at -5. Or you could give me an ordered pair, 0, -5. Now I told you with graphing, you needed a minimum of 3 points. I only have 2. How can I get a third?
You do the opposite of -5 on the other side.
Okay. Take your y-intercept. It is 1 away from the axis of symmetry, so you can go 1 the other direction. That gives you 3 points. If you wanted more, could you plug in some values to your equation? Absolutely. But I have the minimum at this point. What's the domain? What's my range? I want you guys to try it. Can you look at this and tell me if this parabola is going to open up or down? How do you know?
Because
that x squared, if it's positive, it's a normal parabola opening up. If it's a negative, that's the flipping upside down. So I know I should get a parabola opening up. So if something happened on my points and it was opening down, that means I plugged something in wrong. I need to find my mistake. So to get my vertex, opposite of B would be 6 over 2 times A. We get 1. Plug in 1. We get 4. So my vertex is the point 1, 4. Axis of symmetry. It is a line, so you have to give me the full equation, the x value of the vertex. We just usually mark that as a dashed line just to show us that line of symmetry. Y-intercept, put in 0 for x, and you get 7. So you can tell me 7, or if you put an ordered pair, it would be 0, 7. So if I want, that's 1 away, if it goes 1 the other direction, I'm getting a pretty skinny parabola here because the 3 is like stretching it. What's my domain? And my range? 4 to. Alright, this is where I'm stopping today. We will pick up next week and continue with this. I am going to give you a few problems to do. There's like 2 sections of matching within this though, so it's not too bad. So you guys can work on that, and I will bring around tests